Good morning. Today I'm going to be continuing on the previous video. If you're new to the series, the goal of these videos is to document my journey learning the C programming language by reading and reacting to the book called The C Programming Language Second Edition. This book was published in 1988 by Brian W. Kernighan and Dennis M. Ritchie, and it is widely considered to be one of the best resources to learn the C programming language. Now, obviously, the book is pretty old by modern standards, and therefore some things are not exactly the same as in modern C, but I'm currently at page 24, and by now every single example would have compiled and run exactly as described in the book. So maybe old programming books are not as bad as you think. And in the last video, we implemented an example. We implemented exercise 1.13 to write a program that prints a histogram, and this is a fancy word for a graph with bars, a bar chart. And basically, when you pass to it so for example, when you pass a sentence with several words, like the quick brown fox jumps over the lazy dog, when you pass it to the histogram program, it prints one tile for every so basically it calculated that there are 3 words with 3 letters, 3 words with 4 letters, and 3 words with 5 letters, and for each of those statistics it prints one bar like this. Another example, so A, B, 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 C, 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 like this. And it is, so right now the program is has already fulfilled the requirements for the first part of the challenge, and now I'm going to attempt to implement the second part of a challenge, a vertical orientation. Okay, so I'm going to start by creating a directory for the video. And I'm going to copy the gitignore template to 04 because I still haven't figured out how to make a global gitignore that will work. And I will copy 03's histogram, copy the previous program to 04, and cd into 04, so we don't confuse programs from different versions. Histogram C. Okay, so in here we have defined so basically this part of the program is concerned with calculating the counts, and this part is concerned with printing the graph. So we could probably start by splitting those into functions. So we could maybe do it like this, and int max length, and okay, like this. Let's see. So instead of writing inlining all of this logic inside, we could just say count words counts, will it work? So this will be okay. I don't even need to pass a reference. So first we just zero the counter, and then we can inline all of this logic inside like this, and then this definition could actually go down below the main function. So instead of, do I have to, okay, yeah, I need a what does it complain about? Okay, yep. We need a semicolon after this declaration, like this. So I have moved the word counting logic outside, and now bbccc is moving to histogram. Yeah, okay, this is correct. CCC. Okay, this is correct. So we now have a function or a procedure that counts these counts, and now we can define some more logic. For example, we could try to find the maximum amount of yeah, we could first try to split it, and we need to find the maximum number of find the maximum count for a single word length, so that we can start printing the graph from the top down. So make max count for all the counts, and that would be so int max equals 0 for and then we need to know how many, because max counts. Okay, int max length. Okay, like this. For int I equals 0, I is less or equal to max counts. I++, if counts I is greater than max, max equals counts I, and then return max. Okay. And then yes, so we have a function to count the maxes, and then we can define a function to print the graph, and we pass the counts, max length, max count, okay, then the count would be, actually you could just use the counting function inside it. Print graph counts and max length. And then with print graph I mislabeled this variable, max length. So basically, yes, I know we are currently using the same max length parameter for all those functions, and this parameter has a constant value, but it doesn't have to always be like this. So I don't want to hard code it. Just in case we want to test it with some other parameter or something. Yes, and so currently the counts array is kind of like a sparse array, so it would make a good use case for a hash map, but we haven't learned hash maps yet, and I don't know how to implement one, and there is no such type as a hash map in C, so we are out of luck there. Let me see. So yeah, so I'll just cut this and put it in here, I guess. Does it still compile? Okay, it still prints correctly. So yes, so we have the main function and we have the counts in there. So now the counting works correctly, and we can use the counter, like you have to calculate the maximum height. Counts and max length, and this, yeah, okay. So now we know that the maximum height will be the number of rows we're going to have to print. So for int y equals max height. Yeah, we kind of have to start printing in columns, and then at the end we will print the labels in the bottom. So we are going to start iterating from the first row, and in the first row only the only the columns with the actual count like this will be printed. So let's say int y equals max height. So let's say we have the maximum count of 2, and we will we know that only for the 3, but it will only be used for the word 3. Okay. It will only be used for the for three word letter counts. Y is greater than or equal to 1, y minus minus. So we are going for each row, go down with step -1. And then we can iterate from like just like before. So for int I equals 1, I is less than or equal to max length. Yeah, actually, okay, max length I plus plus. If counts of I equals 0, then we continue, because yeah, we don't have to print the column if there is no count. And so if for this word count the height is greater than or equal to the y, then we print this count like this. We can print this 3 times, and a separator like this. Else, yeah, we could use else, or we could use a continue. Print f, just print spaces. And let's see what it looks like. Yeah, so we still have the old graph below, but basically we can see that for 1, 2, 3 we already have bars of different height. So we can probably get rid of the old graph. Okay, and now we can go ahead and go about printing the labels below. So for int I equals 1, I is less than or equal to max length I plus plus. If counts of I equals 0, continue, and then we print f on 3. Okay, so also if max is greater than or equal to max count, return max count else equal return max. So we basically inside this function, by copying the maximum count to max count, we can ensure that no bar will be taller than the max count we wanted. So printf for the space and the I, like this, and then put char new line. So now we have these numbers placed under the bars. And if counts of I equals max count, we can say printf %2 the plus, because there may be more. And then else like this. Let's see. Okay, now we need to print, make longer spaces like this. Okay, so now the bars are centered below the bars, and now we can take a longer text. For example, cut histogram.c to histogram, and now this is still very long, but I'll zoom it out. So we could probably make it shorter by like limiting the maximum count. So for example, we can have a maximum length longer, but the maximum count has to be something like 25 rows at most, like this. Yeah, this seems like it's still yeah. So actually, if we really wanted to print a proper graph, we would have to scale these bars to actually would have to scale these bars down to match the like maximum. So yeah, I think this may be outside of the scope of what I want to do right now. But maybe I could think about it later. Yeah, exercise 1.1.14. Write a program to print a histogram of the frequencies of different characters in its input. Okay, so if we assume we're only working with printable ASCII, frequencies C. So let me go ahead and open the ASCII table. Okay, so the printable characters start from 32 and end at 127, and we just assume that anything beyond printable ASCII is not printable. So we can start by including standard I/O. Define lower limit 32, define upper limit 127, and we don't need to define the state variable because we don't need to define the state variable because the state type, because we are not going to be counting words. And we define counts as the what would be from 32 to 127, 127 minus, okay, upper limit minus lower limit, probably plus 1. For int I equals lower limit, I is less than or equal to upper limit, I plus plus, counts I equals 0, okay. And then we read the input, so while c equals get char is not in the file, if okay, int c if c is less than a lower limit or c is greater than upper limit, continue, because we can just not count the character. And then counts of c minus lower limit plus plus. So when we can print the results, we can first start by printing the results as like a table, and I equals lower limit, I is less than or equal to upper limit, I plus plus. So print f, I think it's %c d, and then counts of I minus lower limit, oh yeah, it would be I and counts of lower limit like this. Let's see, make frequencies and then cut frequencies.c to frequencies. Okay, I think I may have written something like an infinite loop. But I only have one loop. So what's wrong? Upper limit minus lower limit plus 1. Okay, what's going on? Yeah, I'm pretty sure I have something like an infinite loop. Okay, first I cannot undefined it here, so this is minus lower limit. Okay. Yeah, okay, I was overwriting out of bounds. I am surprised I didn't get a segmentation fault. Also, if counts of I minus lower limit equals 0, we continue. Yes, so as you know, C is not a memory safe language, and if you tell it to write at an element above its bounds, it's going to happily do so, even if it ends in a segmentation fault or in overwriting the heap or something. Yep, great. So now it's printing counts, and now we can go ahead and print a histogram. And I'm actually going to just write a horizontal histogram like the last time, because the vertical one is less readable anyway. So define max count 40 or something. So and count equals counts I minus lower limit greater than max count. Yeah, I'm yes, I was honestly hoping if I lower the FPS of the recording to 30, it will not be, the streaming laptop won't be roaring after half an hour of recording, but maybe I'll just have to use a different machine. Int count equals, okay, so printf see like this, and okay, and now for int I equals 0, I is less than count I plus plus, printf, and we need this block character, put char, so now we're getting a histogram of all these characters. And maybe I'll go over this program once again. So first we define a data structure to store all the counts of all the printable ASCII characters. So we define it as an int array of the size of the upper limit, which is the delete character. Oh, actually, is it printable? Whatever. So the printable, for each printable character we define one int in an array, then we zero the array, because in zero you have to initialize your int arrays with empty data, with like zeros, and then for every character in the input we For every character in the input, we see if it's between the lower and upper limit, and if it is, we iterate the corresponding count. And here we are iterating over. So the array is actually not starting at a lower limit or upper limit, it's starting at 0. So we just assume that 0 corresponds to lower limit, so we have to subtract lower limit from I. And yes, we count the characters, and then we print the histogram by iterating over each character in the range. And here we are doing using the ternary operator. If the count at this character is greater than max count, then we just default to max count, and if it's not greater, then we just use the actual value. If the value is 0, we skip this character. When we print the character corresponding to I using %C, this is a printf format string for a char type, and then for every column in the count, we print a bar character like this, a block character like this. And this concludes this exercise. And we can go ahead and enter this section 1.7. 1.7 functions. In C, a function is equivalent to a subroutine or function in Fortran, or a procedure or function in Pascal. Yeah, so I have never learned subroutines. I have never learned Fortran, but Pascal. In Pascal, you use a different keyword for functions that return something and functions that do not return something, and you define a procedure for a function that does not return a value. So this would be a function with a void return type. A function provides a convenient way to encapsulate some computation, which can then be used without worrying about its implementation. With properly designed functions, it is possible to ignore how a job is done. Knowing what is done is sufficient. C makes the use of functions easy, convenient, and efficient. You will often see a short function defined and called only once, just because it clarifies some piece of code. So far we have used only functions like printf, getChar, and putChar that have been provided for us. Now it's time to write a few of our own. Since C has no exponentiation operator like the asterisk of Fortran, let us illustrate the mechanics of a function definition by writing a function power mn to raise an integer m to a positive integer power n. That is, the value of power 25 is 32. This function is not a practical exponentiation routine, since it handles only positive powers of small integers, but it's good enough for illustration. The standard library contains a function pow xy that computes x of the y power of x. Let me see. Okay. Double pow, float, long double pow. Okay. So all of these deal with huge F. Okay. If result underflows, it is not representable, a range error occurs, and 0, 0 with the appropriate sign is returned. If x is plus 0 or minus 0 and y is an odd integer less than 0, a pole error occurs and huge val. Okay. Yeah, this is a lot of math. Okay. Here is the function power and a main program to exercise it, so you can see the whole structure at once. Okay. The power C include stdioh int power int m int n int main int I for I equals 0, I is less than 10, plus plus I, print f, %d%n, I power 2 of I, power minus 3, I. Okay, return 0. And power raise base to nth power, n has to be greater than or equal to 0. Okay. Int power int base int n int ip p equals 1 for I equals 1, I is less than or equal to n plus plus I, p equals p times base, return p. A function definition has this form: return type, function name, parameter declarations if any, curly brace oddly placed in a new line, declarations and statements. So yeah, so obviously now we know that we do not need to place declarations in the beginning of a function, but let's humor this. Make pow. Yeah, looks legit. Function definitions can appear in any order and in one source file or several, although no function can be split between files. If the source program appears in several files, you may have to say more to compile and load it than if it all appears in one, but that is an operating system matter, not a language attribute. For the moment, we will assume that both functions are in the same file, so whatever you have learned about running C programs will still work. The function power is called twice by main in the line printf ddn blah blah blah. Each call passes 2 arguments to power, which each time returns an integer to be formatted and printed. In an expression, power to I is an integer, just as to an I are. Not all functions produce an integer value. We will take this up in chapter 4. The first line of power itself, int power int base int n, declares the parameter type and names, and the type of the result that the function returns. The names used by power for its parameters are local to power and are not visible to any other function. Other routines can use the same names without conflict. This is also true of the variables I and p. vi in power is unrelated to vi in main. Yes, so this is something I've seen many beginners to programming not understand when you define a function. Then these parameters you only have to use these specific names of parameters inside this function, and if you define a function base, if you define a variable named base inside of main and then pass a different, and it doesn't automatically mean that the power function will automatically be called with base. So these are the arguments to a function are the parameters to a function are like local variables. So let me maximize this. We will generally use the parameter for a variable named in the parenthesized list in a function definition, and argument for a value used in a call of a function. The terms formal argument and actual argument are sometimes used for the same distinction. So this means that these are parameters and these are arguments. Or this could be called formal arguments and this could be called actual arguments. Let me write a comment. The value that power computes is returned to main by the return statement. Any expression may follow return expression. A function need not return a value. A return statement with no expression causes control, but no useful value to be returned to the caller, as does falling out the end of a function by reaching the terminating right brace. And the calling function can ignore a value returned by a function. Yep. So this means that the whenever you when does it say return 0? When did they ask to return 0? Oh yeah, actually they asked us to return 0, because before that we never returned 0 from the main function, even though it's implicitly returned like this. And why does he not define an integer type for main and they do for power? Crazy. Yep, so whenever you call return, the function execution ends and nothing after return will be executed. So that's why return can be used as a guard. Okay. And the calling function can ignore a value returned by a function. Yes, so you do not have to assign the return value of a function you call to a variable, and you do not have to use it anywhere else. It will just return a value and nothing will happen. You may have noticed that there is a return statement at the end of main. Since main is a function like any other, it may return a value to its caller, which is in effect the environment in which the program was executed. Typically, a return value of 0 implies normal termination. Non-zero values signal unusual or erroneous termination conditions. In the interests of simplicity, we have omitted return statements from our main functions up to this point, but we will include them hereafter as a reminder that programs should return status to their environment. The declaration int power, int m, int n just before main says that power is a function that expects two integer arguments and returns an integer. This declaration, which is called a function prototype, has to agree with the definition and uses of power. It is an error if the definition of a function or any uses of it do not agree with its prototype. Yes, so this parameter names need not agree. Indeed, parameter names are optional in a function prototype. So for the prototype, we could have written int power int. Well-chosen names are good documentation, however, so we will often use them. Yeah, like M and N actually tell you anything. Yeah, so this is because C uses single pass compilers. So within main, we do not know, if within the main, we need to know that the power function exists. Otherwise, we wouldn't be able to type check this function. This does not apply in modern languages like JavaScript or Go, where you can just define your function wherever without a prototype. A note of history. The biggest change between ANSI C and earlier versions is how functions are declared and defined. In the original definition of C, the power function would have been written like this: power base n, int base n, int IP. I wonder if this would still compile. Okay. Okay, non-prototype. Okay, I'm not sure if the compiler still understands it, but I would be very surprised if it did. Maybe I will do some research and see if such definitions still work. The parameters are named within the parentheses and their types are declared before the opening left brace. Undeclared parameters are taken as integer. The body of the function is the same as before. The declaration of power at the beginning of the program would have looked like this: int power. No parameter list was permitted, so the compiler could not readily check that power was being called correctly. Indeed, since by default power would have been assumed to return an int, the entire declaration might well have been omitted. The new syntax of function prototypes makes it much easier for a compiler to detect errors in the number of arguments or their types. The old style of declaration and definition still works in NCC, at least for a transition period, but we strongly recommend that you use the new form when you have a compiler that supports it. Exercise 115. Rewrite the temperature conversion program of section 1.2 to use a function for conversion. Okay, to be another Fahrenheit. Okay, yes, so I'll just reuse the constants. Int main for int Fahrenheit equals lower Fahrenheit is less than or equal to upper Fahrenheit equals Fahrenheit plus step, and then we use double. What's double T? Okay, yeah. Double T far to Celsius, and yeah, I'll just use double for more precision. Return 5/9 times Fahrenheit minus 32. Oh wow. So we can say printf for the 6.1 f n Fahrenheit to Celsius Fahrenheit. Okay, make Fahrenheit. Yep, still this seems to work as intended. And I'll also use this opportunity to format the function on the left. Great. One aspect, section 1.8, arguments called by value. One aspect of C functions may be unfamiliar to programmers who are used to some other languages, particularly Fortran. In C, all function arguments are passed by value. This means that a function called function is given the values of its arguments in temporary variables rather than the originals. This leads to some different properties that are seen with call by reference languages like Fortran, or with var parameters in Pascal, in which the called routine has access to the original argument, not a local copy. The main distinction is that in C, the called function cannot directly alter a variable in the calling function. It can only alter its private temporary copy. Call by value is an asset, however, not a liability. it usually leads to more compact programs with fewer extraneous variables, because parameters can be treated as conveniently initialized local variables in the code routine. For example, here is a version of power that makes use of this property. Oh, okay. Yeah, okay, so it's reusing the n variable as a... Okay. If this definition is reusing the n variable, which would be the power. Mm-hmm. And this also means that, as mentioned earlier, not this one. Where was it? Okay. So in here, the variables, the arguments we are passing are treated as local variables. Okay. Anyway, today's 1 hour of coding is concluded. I'm a bit more tired than in yesterday's video because today is a Monday and I wanted to get it over with before I get up for work and do other stuff. So it's really early for me and I'm still pretty sleepy. I'll see if I still manage to get anything done tomorrow. If not, I guess the streak will be broken. And I hope you learned something, and I'll see you in my next video.